The Big Bang created the universe and all existence of matter and life. It inflated as an incredibly hot, dense point roughly 13.7 billion years ago. The Big Bang was not an explosion in space, as the theory's name might suggest. Instead, it was the appearance of space everywhere in the universe, researchers have said. According to the Big Bang theory, the universe was born as a very hot, very dense, single point in space. Despite being extremely dense at this time, far denser than is usually required to form a black hole, the universe did not recollapse into a black hole. This may be explained by considering that commonly used calculations and limits for a gravitational collapse are usually based upon objects of relatively constant size, such as stars, and do not apply to rapidly expanding space such as the Big Bang. When the universe was very young, something like 1/100th of a billionth of a trillionth of a trillionth of a second, it underwent an incredible growth spurt. During this burst of expansion, which is known as inflation, the universe grew exponentially and doubled in size at least 90 times. After inflation, the universe continued to grow, but at a slower rate. As space expanded, the universe cooled and matter formed. Light chemical elements were created within the first 3 minutes of the universe's formation. As the universe expanded, temperatures cooled, and protons and neutrons collided to make deuterium, which is an isotope of hydrogen. Much of this deuterium combined to make helium. For the first 380,000 years after the Big Bang, however, the intense heat from the universe's creation made it essentially too hot for light to shine. Atoms crashed together with enough force to break up into a dense, opaque plasma of protons, neutrons, and electrons that scattered light like fog. About 380,000 years after the Big Bang, matter cooled enough for electrons to combine with nuclei to form neutral atoms. This phase is known as recombination, and the absorption of free electrons caused the universe to become transparent. Yet, the era of recombination was followed by a period of darkness before stars and other bright objects were formed. Roughly 400 million years after the Big Bang, the universe began to come out of its dark ages. This period in the universe's evolution is called the Age of Reionization. This dynamic phase was thought to have lasted more than 500 million years, but based on new observations, scientists think reionization may have occurred more rapidly than previously thought. During this time, clumps of gas collapsed enough to form the very first stars and galaxies. The emitted ultraviolet light from these energetic events cleared out and destroyed most of the surrounding neutral hydrogen gas. The process of reionization, plus the clearing of foggy hydrogen gas, caused the universe to become transparent to ultraviolet light for the first time. As the Big Bang continued expanding, more stars and galaxies formed and eventually our solar system was born. Our solar system is estimated to have been born a little after 9 billion years after the Big Bang, making it about 4.6 billion years old. According to current estimates, the Sun is one of more than 100 billion stars in our Milky Way galaxy alone and orbits roughly 25,000 light-years from the galactic core. In the 1960s and 1970s, astronomers began thinking that there might be more mass in the universe than what is visible. Vera Rubin, an astronomer at the Carnegie Institution of Washington, observed the speeds of stars at various locations in galaxies. Basic Newtonian physics implies that stars on the outskirts of a galaxy would orbit more slowly than stars at the center, but Rubin found no difference in the velocities of stars farther out. In fact, she found that all stars in a galaxy seem to circle the center at more or less the same speed. This mysterious and invisible mass became known as dark matter. Dark matter is inferred because of the gravitational pull it exerts on regular matter. One hypothesis states the mysterious stuff could be formed by exotic particles that don't interact with light or regular matter, which is why it has been so difficult to detect. Dark matter is thought to make up 23% of the universe. In comparison, only 4% of the universe is composed of regular matter, which encompasses stars, planets, and people. Dark energy is thought to be the strange force that is pulling the cosmos apart at ever-increasing speeds, but it remains undetected and shrouded in mystery. While much has been discovered about the creation and evolution of the universe, there are enduring questions that remain unanswered. Dark matter and dark energy remain two of the biggest mysteries. However, we can assume that if dark energy remains dominant and repulsive, the universe will expand forever, outliving all the stars and black holes as the universe continues to expand for eternity. And the answer to the fate of the universe, if it will die in fire or ice. Well, it will end in ice as a dark void of nothingness. In an incomprehensible amount of time.
Do not go gentle into that good night. Old age should burn and rave at close of day. Rage, rage against the dying of the light. Though wise men at their end, no dark is right. Because their words had forked no lightning, they do not go gentle into that good night. Rage, rage against the dying of the light.